All right, so we're looking at 7.7 recursive homework. And I have no idea if I'll use this stuff next year. I'm going to say that I have no idea. I will use this work next year, use this stuff next year. I might make new content, I usually do. But for this year, and I'm going to say his name, even Jacob and Tanner and anyone else has to show their work on everything. Caden Smith, you ring a bell too. You don't like to show your work. I don't care how you feel about that. I don't care if it upsets you. The kids who know how to do their work, show the work, they do well. Plain and simple. All right, first one we have up here is 3, and you're supposed to write the first 4 terms of this sequence. It's kind of a funny looking one. It's got a sub n is a sub n minus 1 minus a sub n minus 2. So I talked about in class that a sub n minus 1 is the previous term. So a sub n minus 2, that subscript's wrong, has to be the previous, or twice before. However you want to think about it. It's the before term, the before term. You're supposed to write out the first 4 terms. And I already gave you a sub 0, it's 2. A sub 1 is 4. You only have to find 2 more terms. A sub 3 would be the previous term, which is 4, minus the previous term, which is 2. Anyways, and 4 minus 2 happens to be 2. A sub 4 would be the previous term of 2 minus the previous term of 4, which is negative 2. Recursive rules like this, boy, they really screw with kids, and it's the notation. It's the notation. You have to at least put in your own words what that notation means. If you can't do that, you're dead in the water. Plain and simple. Write a recursive rule for the sequence. The sequence might be arithmetic, geometric, or neither. Obviously, I'm going to be better at finding patterns than y'all are. But I noticed that the pattern, and this happens after the first 2 terms, is the next term is the product of the previous 2. So like, look here, 5 times 15 yields 75. 15 times 75 yields 1125. That's the pattern, all right? So in order to write this thing out, because the next term requires knowing the first 2, I have to define the first 2. And you can call them whatever you want. I'm going to use a sub 0. It's a common thing to do. A sub 0 is 3. A sub 1 is going to be 5. And from here on out, I'm going to take the previous term, which I call a sub n minus 1, and I'm going to multiply it by the previous term, which is a sub n minus 2. All right, 6 is listed. 6 to me looks like it has a ratio. You know, I'm just going to check it. I think 12 over 3 is 4. All right, what else have I got? I think 48 over 12 is 4. I think. Just pretend I'm kind of slow in the head sometimes. It is. All right, so what I do is I know there is a common ratio equal to 4. So the series or the sequence is geometric. And I know geometric form is a sub n equals a sub n minus 1 times the ratio. But you still have to define first term. You always have to define the first term. So we'll use a sub 1 here. The first term is a 3. And from here on out, the nth term, I like to actually put the ratio 4, is a 4 because the ratio was 4. times the previous term. Man, that's lunch. I'm working through my lunch break for y'all. I am working through my lunch break for y'all. All right, for the series 12 plus 4 plus 4/3, find the sum of the 3rd through 12th terms. Now, I notice if I look at the numbers, that 4 over 12 happens to be 1/3. I also know that 4/3, which is the last term, over a 4 happens to be 1/3. So again, I have a ratio being third. And this tells me it's geometric. And the sum formula is, if I can find a pencil, I'll write it out for you. Got to have the right one for the touch screen. There she is. The sum of n items is, and it's actually called a sub 1, but it changes. 1 minus r to the n over 1 minus r. Now here's the thing, that's the first term you want. All right? This is 3rd through 12th. That's actually what we're going to use. Now, I need to know the 12th term. No, I don't. To be able to think about this thing, I don't need 12th term. N is going to be 12 minus 3, add 1 back, which is 10. And so many kids will say it's none. Doesn't matter how many times I say it in class, doesn't matter how many times I say it in a video, you ain't going to pay any attention. You're going to be in la la land. You're going to complain the class is hard when you're the problem. But there are 10 things, and the sum of these 10 things must be the first term you actually care about, which is 4/3, times 1 minus the ratio, which is 1/3, to the 10th power, sitting pretty over 1 minus 1/3. And honestly, we'll just push buttons. That's what we'll do. We'll just push some buttons. Let's see here. We got 4/3. You can use n over d if you want. It's up to you. I don't really feel like it. Parentheses. 1 minus 1 over 3. She is roof-topped to the 10th power. Encapsulate the numerator, divided by, encapsulate the denominator. Let's assume we don't know what 1 minus 1/3 is. I have a habit of wrapping fractions in parentheses. Close. What I'm doing here real quick is I'm counting parentheses. 1, 2, 3 opening. 1, 2, 3 opening. 1, 2 closing. I have a parentheses in there I don't need. Delete. That looks good. 1.9966613. I'd be surprised if the calculator can convert that. It can't. Basically 2. So about 1.99999666613. If you want to do this by hand, it's actually not too bad. It's also not too pretty, and it's probably beyond the standards of this course, so don't worry about it. 14, a pendulum in motion swings through an arc of 21 meters. Each successive swing is 9/10 that of the previous. When the pendulum stops, how many meters will it have traveled? So a pendulum is that thing, you guys have all seen it. You pick it up and then it falls, and then it comes back, and then it swings back. But on its first swing, we covered 21 meters. Its next swing is 9/10 of 21, which is what? 18.9. No, that's not right, is it? 9/10 of 21 is 2.1 times 9. Yeah, 18.9. And the swing after that would be 9/10 of that. which I'm just too tired to do. 0.9 times 18.9. You got to know when you need to push buttons and when you don't. 17.01. This right here is your ratio. This right there is your first term. Now, eventually the pendulum quits swinging from left to right. This is an infinite series. The sum of the infinite series is the first term over 1 minus r. The first term is 21. The bottom is 1 minus 9/10. This is 21. 1 minus 9/10 is 1/10. This is 21 times 10 over 1, which is going to be 210 meters. Eventually that thing travels 210 meters before it rests. It's always moving, believe it or not. It's just to your eye, it quit. It's such a little bit of movement that you can't comprehend that it's moving. It's always moving. Nothing ever stops. Let's see. Oh, I'm going to do all of these. I'm going to do 15 on out. Rectangular prism has a volume of 8x cubed plus 14x squared plus x minus 2 and a height of 2x plus 1. Which expression represents the area of the base of a prism? Now, the reason my hint out here is simple. Volume of a prism is always area of the base times the height. And let me rephrase that. Volume of a regular. That's the actual, what it used to be called. It used to be called a regular prism. Back in my day, that's what we called them. So the reason I have this here is if you divide out the height, you will get the area of the base. That's why that hint is there. So anyways, we're going to do some long division. You could actually do synthetic division, but we're going to do some long division. It ain't going to be fun. I know they're all going to have a 4x. We'll have to go all the way to the end too because of how they differ. Anyways, 2x times 4x squared is 8x cubed. Distribute 8x cubed plus 4x squared. Wrap before you subtract 10x squared. 2x times 5x is 10x squared. 10x squared plus 5x. Wrap before you subtract. Bring down. 1x minus 5x is negative 4x over minus 2. 2x times negative 2 is my negative 4x. I'm going to get stopped there. Choice A. Long division. 5th grade math. Maybe 4th. I learned long division in 4th grade, I think. What is simplified equivalent of 2 minus x minus 1 over 3 minus x? Blah. Blah. It's horrible. So here's the gist on 16. Just think about numbers. Like if you would want to do a third plus 5/7 plus 3/4, you would seek common denominator. And the easiest way to do that would be give this 3, that's 7 and 4. And if you give the 3 that, you better give the 1 the 7 and the 4. This 7 needs the 3 and the 4. And this 4 needs the 3 and the 7. You just give it the stuff it doesn't have. So that 5 has to get a 3 and a 4. And that 3 has to get a 3 and a 7. I didn't change the number, I just changed the appearance. But that's the gist. Give things what they don't have. So let's go up to mine. Here's a 2. It's over a 1. It's going to need that 3 minus x down low, which means it's going to need 3 minus x up top. There's minus an x, so minus an x. It's over a 1. it too is going to need that 3 minus an x. And that means I need it up top too. And here's a minus a 1, and it already has 3 minus x, and it doesn't need anything from the previous guys. What I've done now is I've created a common denominator. Distributive property says that is 6 minus 2x. There's a minus here, so minus whatever I get. 3x minus x squared minus, so minus 1. And then I combine like terms. I'll have a positive x squared. I've got a negative 3x minus 2x, which is minus 5x. Get rid of that stuff so I don't have to look at it anymore. I have 6 minus 1, which is plus 5. Choice C. 17, great non-calculator thing. Which expression is equivalent to this? Trying to think if I should actually work with I squared or not. I don't think I need to. Interesting idea. I do. This is the imaginary root of 6 times the imaginary root of 4 minus a real root of 3. I think it'll make a bit of a difference, you know. It's one of these things, the ACT likes questions like this too. They want you to realize it's imaginary. So when I multiply these together, I get I squared roots of 24. And then minus, yeah, I had to do it anyways, minus I roots of 18. And I'm going to go through the radical simplification step. Now I know I squared is negative 1. So this is a negative 1. 24 is going to be 4 times 6. There's an I. 18 is 9 times 2. Root of 4 is 2. Negative 2I root 6. Root of 9 is 3 minus 3I root 2. Which they don't have, do they? Oh, that's negative 1. Negative 2 root 6 minus 3I root 2. There we go on that one. 3 more to go. Still working on my lunch break. This one, that's QF. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. So, opposite of a positive 5 is a negative 5 plus or minus square root b squared minus 4 times a, which is 1, times c, which is negative 3, all sitting pretty over twice a 1. 25% of the junior class can't do that. It's actually higher than that. It's probably closer to 50 when you include little mistakes. I just don't know what to do about y'all. I really don't. This would be a non-calculator question, by the way. That's 25 plus 12, root 37, both pieces over a 2. One bad is choice B. 19's got a product. Notice it says product. That means we multiply. I'm sure they have an option here where the kid adds. 2 and 3 makes 7. Oh, they didn't. Okay. Anyways, just do the double distributive property. 10 minus 8i minus 15i minus 12i squared. Negative 12i squared is negative 12 times negative 1, so plus 12. 10 12 makes 22. Negative 8, negative 15 makes negative 23i. Perfect. Choice C. Then we have a simple function composition problem. What is f plus g of negative 1? This means do f of negative 1 and add to it g of negative 1. That's all it means. So f of negative 1 is going to be 3 times negative 1 squared minus a 2. That's 1. That's 3 times 1 minus 2, which is 1. G of negative 1 is going to be 4 times a negative 1 add 2, which is negative 2. And 1 plus a negative 2 is a negative 1. Done. You're welcome. That was my entire lunch break. You're welcome.